Here we are, reviewing from yesterday. I forgot to actually put the video up, so it's all their fault, right?
Yeah.
All right, so here we are. I'll review quickly what we did yesterday. And basically all we said was, if you have a perching boulder, right, as still as can be. Imagine this is not even quivering. No gravitational waves are hitting it, nothing. It's just sitting there still. It has what kind of energy? Could you review that for me, Emily 1?
It has all potential energy.
All potential, right, because it's not moving, so it's no kinetic. And what else happens down here right before it hits? Because potential energy involves height, so M2, what happens down here?
It has no potential energy, because the velocity is 0? Wait, no, hold on.
What's that? No, the velocity right before it hits. We actually calculated it, yeah.
The height is 0.
Okay, and so it has all what?
Height.
And then what happens in the middle, Zach?
In the middle, there is less potential energy because it's going down,
Right.
and there's more kinetic energy
All right.
because the height is going down as well.
Then we went on. I'm not going to do a problem because we did them yesterday, but you could tell us how. We asked the question, how do we get the velocity right before it hits?
Well, you see, we can use the squall equation.
So, MK, tell me what we do with that. No, tell me.
Force of friction.
How do we take that? Yesterday I gave you numbers and everything, but what do we do to find the velocity at the bottom? When I say at the bottom, I don't mean when it's hit, but the instant before it hits. What was our strategy? If we're looking for velocity, which formula must we use? Which one has velocity in it? Is it P or KE?
Kinetic.
All right, kinetic. So we're going to have kinetic energy. So that's 1/2 mv squared. And what do we end up setting that equal to, strangely? Do you remember what we did?
You set it equal to P, but it's at the top or something?
Right, exactly. So why can we say KE at the bottom equals PE at the top? Does that make any sense at all? Can you explain that, MK?
Okay, so the equation's TE equals PE plus KE.
Right, exactly. We know that total energy is going to be the sum. Total energy is the sum of PE, potential, and kinetic. So, at the top, this was 0. At the bottom, this was 0. But they had the same total energy at both spots. So therefore, we could take kinetic at the bottom and set it equal to PE at the top. And that's exactly what we did. So, shocking, wasn't it? All right. So that's how we found, and we were able to solve that. We knew everything and solved that for V. So sorry I forgot to put the video on. But that's the theory behind what we did yesterday. Okay? All right. So then we revealed to each other that we knew how to do this problem all along from chapter 2 using the squall equation. But this is better because we don't need to have straight line motion like we did in the past. So we're going to graduate to this. So take your pencils now, Video Land, we're at the same spot as you. So if you would, draw this roller coaster ride. And I will remove this yesterday's old news.
It's just a clock. You can use a spin one.
Sorry.
Thank you. Is anyone not a roller coaster rider?
I love that.
Now we all like roller coasters.
It's gonna be good when we go to park.
Can you ride them? There's always some that can't do it. So.
We can
I heard that
argue.
it's
Can we
not
all
possible.
do
Go like
it?
straight down, like it's like
It
a
is
9-degree like moves, just like
Right.
I love
that.
Fahrenheit. The Fahrenheit. I rode
Have you been to Cedar
Fahrenheit.
Point?
Because we actually have to do
This
Never
is
heard of
like
that.
a dragster and
like with physics, we have
so
to
you're like 200
measure the
miles per hour.
G's and stuff.
Oh my
like
goodness.
Better keep your head
Yeah.
I've heard
back.
it's really
Oh my
easy
God,
to do that.
that. Yeah, you just take the, she gives you a little thing.
Like the entire
and you
roller
hold
coaster
it.
is literally just go
Really?
up
Yeah.
and then
Oh.
down.
Let's go in Fahrenheit.
Well,
Fahrenheit
just with a few calculations or with few
Got it.
numbers known, like suppose, like if
Oh,
if you go to Hershey Park,
Yeah.
they'll actually tell
So-
you in a little
Oh, guys, there's
handout
an
what
air
these
of
heights
experiment.
are.
You have to go on the roller
So
coaster
you'll be
again.
able to do what I'm teaching you right now. So I want you to find the velocity.
I like it.
We'll mark this point A. You have the sketch. Get the 113, the 22, and the 67 meters. Indicate the mass is 546 and it's starting out still. So it's sort of building anticipation that puts you on the top and stops you. And then zoom. So we want the velocity. This roller coaster problem isn't going to be quite as good as the one you will ride on because this one actually, when it starts from still, it's no mechanical advantage to it. Nothing's pushing it. So it's just going to fall down the track. So it won't be quite as nice as the one you'll be on. So we'll start out with a boring one. So call this point A, call this point B, and call this point C for reference. And I want to find the velocity at B and C. If it's starting from still and it's going down these slopes, what will the velocity be? Do you think it'll be very big at B or C?
No.
Or do you think it'll be higher, B or C?
See.
All right, well, let's find out all these questions. All right, calculators out. Everybody's going to tap out everything today.
Tippy tap.
So we're going to be tippy tappers. Let's find, to do these problems, even without thinking of what is given and what is asked for, we always need total energy. So where can I go to find total energy? I can go any spot I want to because total energy is the same here, 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 here's total energy is the same everywhere. So everywhere I go on the whole picture, TE is PE plus KE. But where is a spot that I can go right now and find total energy? I know everything I need to know to get it. I surely can find it right here, but I don't have any information about that. So where would I go, Alex, to find total energy, where I know the most?
Would you go towards the middle?
Right here,
Yeah,
point
yeah.
B. At point B, we have some potential energy because it's above the ground, because potential energy is tied to the height. And we have some kinetic energy here because it's in motion there. So I would have to add the two to get to total energy. And right now, I don't have enough of that information. So pick another spot, Brian. Where else could I go?
I'm just trying to write things down.
Remember, PE is mgh and KE is 1/2 mv squared. So where can I go to find total energy? Right away from the beginning.
Alright, so we go, you can pretty much find total energy anywhere, right?
You can if you have the information. So where do we have the information right now to get it? What point?
So at B, you have height, you have G, and you have total energy. If it's the same, that is.
You could get mgh right here, but because it's not
No, it's
still,
potential energy, and that would need to be kinetic energy, right?
right here we'd have to add both, PE and KE, because we have a little of both. But right now, we don't know velocity at that point, so we can't do it right this second. We will be able to, but right now. So where can I go now?
Do we have T? Do we have total energy right now?
No, that's what I'm asking.
Okay, so we have everything else, but we don't have velocity.
Right, we don't have velocity. So where can I go to find total energy where I don't need velocity?
KE, right?
Right
C would
now.
be the same case.
Yeah, find the
So I
velocity,
guess
so that's
let's
a
go with
total.
A, right?
Great, okay, A.
Oh, we already got
So-
that one.
So total energy
Yeah.
But don't you
I'm
just
going to
subtract
go to
22?
point A and say, notice how I indicate that to my readers, that's you all. I put a little sub A there to tell you where I went. So total energy is potential energy at A plus kinetic energy at A. So tell me what these numbers are. Can you, without me telling you? Emily, one. Do we have an MGH at A?
Yes,
All right, what are those numbers?
546,
Uh-huh,
9.8,
uh-huh.
and 113.
All right, very good. MGH, there it is. All right, and so also M1, what is the kinetic energy at A?
0.
Right, so see how nice spot to go to find total energy? It works, so I need that. 2 sig figs, you have it, MD?
For
I have,
velocity
well,
at
I
P.
did it in scientific.
That's
I
fine.
got 6.0 times the
Right, if we wrote
No.
60, it wouldn't truly,
Yeah,
or 6000, it wouldn't be.
yeah.
All right, so she wrote it like this.
600
We have to do
whatever.
sig figs as we go this chapter, so it's gonna be a little bit of an
It's
aggravation.
gonna be a roller coaster ride.
Yes, it will.
Total
All right.
Horn,
So-
horn, horn.
All right.
So rolls.
Oh, they're still fine.
Yeah. Oh, no.
All right, I forgot to time
Mine
this.
makes
How long have we gone? 10 minutes, you think?
Yeah, probably.
Yeah.
Decent amount.
6.0 times
All right.
2 is that.
We're gonna come back here in part 2 then.
May the force be with you.
Ha 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 ha.
They can't see me,
ha.
so it's not funny. May the force be with you.
Well, you might know if you don't laugh.
All right, did you,
Oh, so
did
no,
laugh,
you
don't
stop
laugh.
it?
No.
Go ahead, we're gonna come back. We didn't time it, so we're gonna shut down now and come back in a second.
Ray says bye.
Ready?